So in this video I'm going to run through the answers to exercise 2 from 6.2, and I'm just going to focus on question 6, which asks you to determine if a molecule is polar or not. So the first molecule I ask you about is H2O. In order to work out if this is a polar molecule, the first thing you need to ask yourself is, do you have any polar bonds? So the bonds I've got are hydrogen-oxygen bonds. Are they polar? The answer is yes. The reason they're polar is because there is an electronegativity difference between hydrogen and oxygen. Oxygen's far more electronegative, so I do have polar bonds. Then I need to ask myself, do I have perfect symmetry? If I do have perfect symmetry, then my polar bonds will just cancel each other out and it will be non-polar overall. If I do not have perfect symmetry, the polar bonds do not cancel out and I do have a polar molecule. The way I've got it drawn here, it's hard to see if I've got symmetry. So the best thing you can do is work out the shape of the molecule, and the shape will tell you if there's symmetry. Around my central atom, oxygen, I've got 2 bond pairs and I've got 2 lone pairs. That means that the shape is non-linear. Non-linear is not a symmetrical shape. So both of the shapes that involve lone pairs, non-linear and pyramidal, they are not symmetrical. So this is a non-symmetrical molecule, and it does have polar bonds, meaning it's a polar molecule overall. If you don't have symmetry and the dipoles cannot cancel, then it is a polar molecule, and this is not symmetrical because it's non-linear, and non-linear is never symmetrical, even if it looks it the way I've drawn it on the page. Next one is beryllium bromide. I've got BeBr2. Beryllium has got 2 bond pairs around it. So the first question I'm asking myself is, are my bonds polar? And the answer is yes, there is a difference in electronegativity between beryllium and bromine. Now in this case they tell you the values associated with beryllium and bromine, because we never usually use beryllium, so you wouldn't be expected to know that off the bat without looking at that table of electronegativity values. But you do have polar bonds, and then you need to look and see if you've got symmetry. Now I know looking at it, it looks like I've got perfect symmetry, but I need to work it out using the shape. It's not enough to just look at how it's drawn on the page. So I need to work out the shape. Beryllium has got 2 bond pairs and it's got no lone pairs. I know there are no lone pairs because it's in group 2 and it's forming 2 bonds. It doesn't have any of their electrons left over. So 2 bond pairs, no lone pairs. That means the shape is linear. Linear is a symmetrical shape, so I do have symmetry. If I've got symmetry, then the dipoles will cancel out, and even though I've got polar bonds, I've got a non-polar molecule. NH3, do I have polar bonds? Yes, I absolutely do. There's an electronegativity difference between hydrogen and nitrogen. Do I have symmetry? Again, I need to work out the shape. I've got 3 bond pairs and 1 lone pair. I know there's a lone pair in nitrogen because nitrogen's in group 5. It's got 5 electrons on its outer shell and it's only forming 3 bonds. That must mean there's 2 electrons left over. It's got a lone pair. If it's got 3 bond pairs and 1 lone pair, the shape is pyramidal. As I mentioned above, shapes that have lone pairs are not symmetrical. So I do not have symmetry. If I do not have symmetry, the dipoles do not cancel and it's a polar molecule overall. A BF3, do I have polar bonds? Again, the answer is going to be yes. Fluorine is your most electronegative atom. It's bonded to anything. That bond is going to be polar, so I've got a polar bonds. Do I have symmetry? I look at the shape. Alright, I've got 3 bond pairs. There's no lone pairs. I know there's no lone pairs because boron's in group 3. It's only got 3 electrons in its outer shell and it's forming 3 bonds. So there's no electrons left over. It's just got 3 bond pairs. 3 bond pairs is trigonal planar. Trigonal planar is a symmetrical shape. So yes, I've got polar bonds, but I've got perfect symmetry. Those dipoles will cancel, and it's non-polar overall. Next one, SiCl4. Do I have polar bonds? Yes, I absolutely do. Chlorine is quite electronegative. I've got polar bonds. Do I have symmetry? I need to work out my shape. I've got 4 bond pairs surrounding silicon. I don't have any lone pairs. I know I've got no lone pairs because silicon's in group 4. It's only got 4 outer shell electrons and it's forming 4 bonds, so there's no electrons left over. 4 bond pairs, no lone pairs is tetrahedral. Is tetrahedral a symmetrical shape? It absolutely is. So yes, I've got polar bonds, but I've got symmetry. The dipoles cancel, non-polar overall. Next one, CHCl3. Do I have polar bonds? Yes. Okay, not all of the bonds are polar, but the carbon-chlorine bonds are polar. Doesn't matter that the carbon-hydrogen bond is not. I do still have some polar bonds in there, so I can tick yes for polar bonds. Do I have symmetry? Carbon's in group 4, it's got 4 electrons inside a shell, and it's forming 4 bonds. So I know there's no lone pairs on carbon, there are 4 bonds, that makes it tetrahedral. So I have a symmetrical shape, but do I have symmetry? The answer is actually no. Even though I've got a symmetrical shape, not all of my bonds are the same. I don't have perfect symmetry because up here I've got a hydrogen and everywhere else I've got a chlorine. Okay, so it's not perfect symmetry. It's only going to be perfect symmetry if you've got a symmetrical shape, so linear, trigonal planar, tetrahedral, octahedral. You've got one of your symmetrical shapes and all of the bonds are the same. In this case, I've got a symmetrical shape, but the bonds are not all the same, so I do not have symmetry. If I've got polar bonds and I don't have symmetry, it's going to be polar overall because the dipoles won't cancel. Next up, do I have polar bonds? And again, the answer is yes. Not all of the bonds are polar, just the carbon-oxygen bond, but that's still enough. Do I have symmetry? Again, what shape do I have? I've got 1, 2, 3 bonding regions. Remember, a double bond is just one bonding region. 3 bonding regions gives me the shape trigonal planar. Trigonal planar is a symmetrical shape, but in this case, do I have perfect symmetry? The answer is no, because I've got hydrogens and I've got an oxygen. Not all of the bonds are the same. So despite having a symmetrical shape, I don't have perfect symmetry. If I don't have perfect symmetry, the dipoles can't cancel and it's polar. Last one, SF6. Do I have polar bonds? Yes, I absolutely do. As I mentioned already, fluorine's the most electronegative atom. Do I have symmetry? I've got 6 bond pairs around sulfur. I've got no lone pairs. I know I've got no lone pairs because sulfur is in group 6. It's only got 6 electrons inside a shell and it's forming 6 bonds. 6 bond pairs, no lone pairs is octahedral. Octahedral is a symmetrical shape and all of my bonds are exactly the same. I've got perfect symmetry, my dipoles cancel, overall it is non-polar. In order to be able to do these, you do need to be able to work out the shapes of your molecules. If you are struggling to work out the shapes, watch the previous video from 6.1 where I go through drawing the shapes in detail. Other than that, you just need to know which shapes are symmetrical and which are not. The 2 that are not symmetrical are the ones that have the lone pair. So the non-linear 2 bond pairs, 2 lone pairs, and the pyramidal 3 bond pairs, 1 lone pair. They are your non-symmetrical shapes. The other thing to look out for in terms of symmetry is, are all of the bonds exactly the same?